to build Propulsion Lab at Devoxx UK. Come to live from London. And my next guest is Yassine. Welcome.
Hello, thank you for
Thank
having
you.
me.
Thank you for being here. And I understand that you spoke about something very interesting in the conference yesterday about porting Doom to a web browser.
Yes,
Porting Doom is a thing. Everybody are porting Doom to everything,
Yes.
right? Including like kettles and toasters. I guess you didn't go that far,
no,
but browser was an interesting choice because you used a very popular and very promising technology to do that, and that's WebAssembly.
yes. So WebAssembly is a binary execution format, was made initially to run alongside JavaScript to run compute-intensive tasks in a more optimized way than JavaScript. But now it runs on many outside of the browser, thanks to WASI or other technologies, for example. But for my work, I used just the web browser part, and many frameworks support compiling directly to the browser. So they compile their runtime or their code into WebAssembly, and it can run within the browser. We have .NET that allows this, Kotlin also, with Kotlin multi-platform, and many other frameworks.
Yeah, that's WebAssembly looks very promising as something that will solve a lot of JavaScript problems. We want a language which is which is like for the most common platform in the world, which is the browser.
Yes.
And we definitely don't want to write it in JavaScript. So you use .NET, but the original Doom's code is not in .NET, obviously. It is C, I guess. C. So first you needed to port the code from C to .NET. How that works?
So I didn't do this. This was a port that I forked from GitHub. So I took a port of Doom to .NET, which is on GitHub. I cloned it, forked it, and then ported it to the browser. So it's a port of a port.
So basically you took an existing port
Yes.
of Doom from C to .NET,
Yes.
and then just you packed it in the WebAssembly.
Yes.
And what was this process like?
Yeah, so the process was like I took the source code and then modified the project to, instead of building to the desktop, configured it to build using WebAssembly tools and to the browser. And then I get errors and fix, reverse engineer little by little, you know.
This is interesting. So obviously I would say, okay, that sounds like a 20 minutes project. You already take existing code, you change a couple of configurations from compiling to browser to compiling to WebAssembly, and you're done. But it wasn't.
No, the case.
So what kind of incompatibilities, what kind of errors, what kind of problems did you encounter? Because by the looks of it, it should be absolutely seamless. So what happened?
Yeah. So the Doom port that I used the library called SFML, which is a multimedia library, but it only works on desktops. So there is no implementation for the browser. So this has to be re-implemented again using JavaScript APIs. So Canvas and also the Web Audio API. So it allowed me also to learn these new APIs that I haven't had the occasion to use before. So that was a really good way to do this. The other thing is, when you develop a game, you have a for loop that iterates 60 times per second, 30 times per second, but you can't do a for loop in JavaScript for games. You have another API which is called request animation frame, which makes a recursive call to your game loop, and it handles frame pacing. And when you close that, or when you switch to another tab, for example, or disable your browser, it stops automatically the game loop. So it's like an optimized game loop for browsers.
All right, so you had to replace the entire graphics library with the JavaScript graphics library, and that brings a question of interoperability within WebAssembly. So you kind of run both the JavaScript libraries of WebAssembly and the .NET libraries of WebAssembly together.
Yes.
How easy was it to make them work together?
So in the beginning, it was not very easy because the initial way to do WebAssembly in .NET was using a technique called Razor components. So the initial way to do the WebAssembly in .NET is like Angular React or Vue. You write web components, and then instead of using JavaScript, you use .NET. That was the way to do WebAssembly initially in .NET, or the only way. And I had to do some intricate things to get my canvas and my JavaScript interact with it. Because I'm not doing a web component or this kind of stuff. It was not done for this. So in any case, I found a way to make my game loop of run inside this. But since .NET 7, there was a more direct way or more general purpose way to use WebAssembly with .NET. It's just like in .NET you write JS export to make your .NET function visible in JavaScript, and you can have also the JS import annotation to access JavaScript functions from .NET, and the opposite also. You can call .NET code from JavaScript, and you can call JavaScript code from .NET.
This is pretty cool. I mean, they made this interoperability very easy.
Yes.
And then you needed, but what you needed is to use this graphics library in .NET. So you use the import.
Yes. So in .NET, when there was a call to the SFML code, I hijacked or removed all this, and then called JavaScript. So I imported the JavaScript.
Yeah, that makes sense. Wow, this is very cool. How we can play the game? How we can see the code? Where do we go?
So you go to GitHub. In my GitHub repository, you search Yassine, manage Doom Blazor. You can have in the README you have a link to the demonstration. It runs on the browser. You have your what's funny is that .NET compiles to DLLs. So you have DLLs running in your browser now. So if you they are everywhere now. And it even runs on your phone, so you can even try it on your phone. It's WebAssembly, it's web standard, so it also works.
This is very cool. Yassine, thank you very much for sharing that with us. It's a cool project. You really should check it out. And we will be back with more interviews in Propulsion Lab, DevNexus, right after this. Stay tuned. Thank you.
You're welcome. Thank you.